Well, this has got to be at least worth a mention. Worth mention. I'm online here, and I'm trying to think of what could possibly have caused that bug, right? And I forget what I was typing. Something like wait, yeah, like that. But I don't know if that was the one that took me there. That's not it. I did go to some pages. But anyway, I go to this page, and it must be an Intel page. Here, yeah. VERR, okay, verify read is a thing, an Intel 386 instruction. Which I thought maybe you have to call this to make sure that if there's been a thread switch, that the segments have been loaded, right? So here I jump to it, and of course I'm thinking, God, this is just like that MIT thing. They don't give a single example. I was trying to type in the code, right? And I thought I was supposed to type VERRFS, because all I see here is VERR and then either registry or memory location 16 bits, right? Well, the compiler is telling me that I have an invalid operand type. So I'm trying, again, I have to go and experiment. But the funny thing is, I'm looking at this and I think, boy, this sure looks a lot like that MIT thing, maybe that's the standard format. And then I realized, looking at this, wait a minute, this is the MIT thing on Intel's site. I mean, it can't be that Intel wrote this because now this is another case where I'm going to use the thinking trick. Intel didn't write this page. I can be certain of that for the following reason. This page has corrections. That is, as one example, this here is a correction. These little eyes here, this was a typo in the HTML, and this page didn't exist at the MIT site. This page did. I don't know if it's capital T. Looks exactly the same. Okay? So that's not the only one. There are other corrections. Now, people don't usually copy something and then take it and make a whole bunch of mistakes and add typos and introduce bad links. If something's corrected, then if something is a version of something else and contains the same typos and then corrections for those typos, in addition to other corrections, then the original is the one with the mistakes, not the one with the corrections. So I thought that was kind of an interesting thing, that this reference is so good. Intel themselves have chosen to make it their reference manual for the CPU, and it is. It's such a great reference. It's so well organized. You can't. like I said, I can't think of a better way to approach learning a complex system like this. Speaking of which, I noticed something as I was watching the last one. Remember, maybe you skipped over it because it was so painful. I spoke about this TLS data, thread local data. Well, it turns out there's another TLS thing in the same structure. There's one called TLS something or other. Here, TLS array. And if you recall, the value here contains a pointer to itself, right? Now I think that when this thing is pointing, contains a pointer that points to itself, then I think that one is meant to take that as meaning that the TLS data is in these slots, for which there are only 64 entries. However, if you go and look at the help file, there's a reason why that came up quick. TLS. Now, one of the reasons is my system is running incredibly fast now. Out of indices. Let's see now. They mentioned the number of available indices. That's another thing I forgot as I was looking at that, is that TLS alloc, the function allocating thread local storage memory, takes an index value, right? And you have to pass that index in when you retrieve or write to your slot. Everyone gets a slot, 4 bytes. And there was a maximum number of slots. Where was that? Get value here. Now it says NT and Windows 95 have 64 indices per process, and XP and these. Now, of course, Windows 7 and Vista and all that didn't exist when this was written. So I'm guessing, because there's 2 entries in the table that have to do with TLS storage, thread local storage, I think that these are your default for 64, and if you want more, the system will provide them, but only after you've exhausted those 64. And now I can test that. I can just keep adding new ones and see what happens. Maybe I will. Of course, we'll find out. But first, I'm trying to build this structure just as it's laid out on the wiki. Wiki. Okay. No. Yeah, that's it. Thread information block, where I found that table. The one I copied and painstakingly put into a text file. Now I'm going back to the original. This one has links. If I've read this correctly and haven't made a mistake, this is all contiguous. There are no gaps. I've also misread this. This is the NT subsystem independent part. So this part is not dependent on the NT subsystem. So I had it backwards. Anyway, and the rest of it is NT subsystem dependent, meaning I suppose that depending on which type of NT you're using, it has a different meaning. And in fact, you can see what these subsystems are referring to are the subsystem. Well, Windows version, I think, is what they mean by subsystem. This is not NT at all. But I don't know what this wine is, but maybe wine is a category of NT. But they show you, like taking this one, for instance, at 44, in brackets it has NT here, so I think that means that if it's NT, then this 124 bytes represents client information, Win32 client information. If it's wine, whatever that is, then it represents user 32 private data, totally different. And if it's Win95, then only offset 60 to 60 up to 64, non-inclusive, is the last error code for Win95, so 60 to 63 inclusive. And for Windows ME, at offset 74 is the last error, so 74 to 77. So that just covers this entire 124 bytes, and within this section only 4 of them have meaning for these two. All of them have meaning for this thing, whatever it is. The same for NT. Now this is only NT. Again, NT. Oh, maybe WY. No, because it's. Maybe this is like Win-E, Windows, like other, Win extra or something. I don't know. Anybody knows? Let me know. Unless it makes sense eventually. Here there's just 9x and t. Same with all of these. No wine. It has to be this wine that's a different subsystem. Right? This doesn't depend on the NT subsystem. This does. Now, where do you see an NT subsystem in here? This is not NT. So that leaves only one. Okay. Time for another search. Now this really is going too far, but oh, I know. Windows wine software. Oh, that's Windows CE. No, wine will not run CE. I'm probably just totally out of it. Everybody probably knows what this is. It's a free open source software application that aims to allow applications designed for Windows and Unix-like things. Okay. Allow them to run. Oh. So I can run Notepad on Wine, possibly. Wine lib, and you can compile against it. Compatibility layer duplicates that. Windows programs run in a virtual machine. Yeah, well, what's new about that? Black box testing to avoid copyright issues. Wine is a compatibility layer. I see. It duplicates functions of Windows by providing alternate implementations of those DLLs that Windows programs would call, and a process to substitute for the kernel. This method of duplication differs from other methods that might also be considered emulation, where Windows programs run in a virtual machine. Oh, okay, I see. Wine is predominantly written using black box testing, reverse engineering. Is it black box testing or reverse engineering? Because those are different, to avoid copyright issues. Reverse engineering is not allowed, right? That is protected by copyright. Like whenever you read those copyright notices, it always says, when you install a program, it always says you the customer will not make any attempts to reverse engineer this software, blah blah blah. So, but black box testing is not reverse engineering. Well, all that is you don't make any attempt to try to figure out how the thing works. You just want the same output for the same input, So you don't know anything about what's in the box. You just want to make a box that emulates the functionality of another box without knowing what it is. Windows emulator, I see. Its meaning later shifted to the recursive backronym. Wine is not an emulator, I see. Wow. Recursive backronym. I've never heard that before. Why is it recursive? NU. An acronym. Wait, what's a backronym? Okay, now I'm on to the diversions. I'll get back to this in a minute. I found out what that word meant. It's a backronym is like a phony acronym, like you started with the word that you wanted to turn into an acronym by creating the phrase. You made the phrase fit the acronym that you want. So here, this number I got out of the, what I did was I just cast that thread information block as a pointer to the struct I took from Wiki. Oops. See? And I'm not 100% sure, but it certainly looks like that's the one. The last time I ran this, it was index 16. This time apparently it's 17. I used the same index for all of the threads, and I put that in here, and I went into the watch, and I cast. It looks like the right structure because I see it D54, and that happens to be the ID of that thread. And therefore that makes this a TS string of length 7. if this were a TS string, it has two members, a length and a pointer to character buffer. And so I cast that as that pointer as one of these structs, which is a member of thread, which is in a common namespace. And after it kept complaining until I fully qualified it, and then here it is. That is certainly. That doesn't look like a coincidence to me. Okay, now let's just see. I want to make sure that it's at the right spot. Maybe that the number you get past is not the same as the index. So we're on the breakpoint. This thing, I guess. Set thread name. Well, I don't know if I use that interface. I certainly call it. Okay. So that says 16. Now, where am I doing this from? Here. Okay, now here are the locals. This is the struct TIB. And I must have typed it in right. No, that slot's that array is way down near the bottom. Although this could be part of it. I could have it wrong. Definitely it's 17, right? And that's the string, same as before. The question is, am I off by 4 bytes in my positioning? Like is the index really whatever I say plus 1? That would mean I wouldn't get 64 blocks, right? It wouldn't be possible to use block 0. I don't know why I got 22 here. It's actually 23 in decimal. What can I tell? What else would can I identify around here? PTLS data. Oh, that's not in the struct. Error mode, UDN. This is local. This thing, TLS links. I think that has to do with when it gets extended. We'll find out. I don't understand why you call TLS out. Well, I guess other things might not have filled their slots in yet, right? All of these apparently are allocated, and only this one's been used. And that one has got a. I don't know what this number is, or numbers. Actually, the 8B. Now, it looks to me it looks like 2 points or something, like coordinates, you know. If you were thinking in terms of x and y, but if you can't, well, could be, because there's a lot of stuff in here in this struct to do with GDI. GDI, all this GDI. There's something called a GDI pen, a GDI brush. GDI is a great big data structure here. TEB, thread something block. for GDI. Activation context stack. I wonder what that is. Something to do with like ActiveX? Probably. Win32 client information. That has a pointer. I don't know. Wait a minute. How come it's interpreting that way? It's an array. Oh, I see. It sees it since it's bytes. It sees it as a string. Okay, process environment. That makes sense. Last error code. Oh, I could cause a winter. That's what I can do. What we can do here is set error, set last error. By. And if the position of that error code is in the right spot, then it should turn to a 5. So we time. Okay, I'll just try this. I know I'm avoiding that. I'm avoiding the issue, right? That structured exception. But this is a great big structure with tons of information in it. I'm curious about it. Well, it should work with this one, with name or anything. There it is. See? It worked. Okay, so we're good up to here. Now, what else can we check? Locale is the 409. That's I know that's correct for English. U.S. In the U.S. What else? What do we identify? Now, here's something that's of interest I find. And this looks like we're off. I think this should be down. I think I'm off here. Well, I'm not sure, but there's something called a real process ID and a real thread ID, and why would that be 0? But we've got a brush to find, but no pen. Seems to me that I've miscopied something. So what changed? The real thread ID should have. No, it did. It's all 0. Unicode string. Same as before, 17. I think, let's see now, if that 16 was supposed to be the right answer, what would that say about, well, where did we get last error? There. About everything. That means I missed something. I gotta add one more D word. That's possible. Could be missing one D word. What? I'll keep looking for that, and I'll just encode this. And I want to add just quickly on the end of this video a quick look at the structured exception frame structure. Okay. Okay. I'm going to just, I'll end this one here and show you that I found out where I was off slightly with this buffer, and I had to find this too small. I'm not sure exactly why. I mean, why it worked out evenly, but probably there was padding because I was off by 3 W cards, which is 6 bytes. But the the position of the entry was off by 4 bytes, so it probably somehow, you know how these things pack in a funny way. I'm not sure how, but it should, I'm pretty sure it was saying 17 last time. Now it's 16, which is what it should have been. And I'm printing that out at the beginning now, in fact. Beginning of every time any program runs now. I'm calling the TLS alloc. Okay, no, it doesn't matter. You can use this one index for your, everything you need as far as thread local storage uh, for all of the threads in your process. So, and you don't need to free this. It says that you should, in the help, it says that you should free them, but for the life of me, I can't see why. If a thread dies, then so should its, it's the local descriptor table. Oh, but maybe there's memory allocated. I'm not so sure exactly what they're talking about. They might be talking about freeing your own memory. Because there shouldn't be any need to free it. Certainly for the main thread, it's 4 bytes, and the only time you would free it is at program termination. So there doesn't seem to be any reason to free it there. It's just a static. And let's see now, free. There were some comments before. If threads have allocated memory and stored them in slot, they should free memory before that. Sure. Yeah, sure. See, I don't think that it matters because if a thread dies, all of the data associated with it, it's thread local data and everything should get cleaned up by the system. The only reason you would free one of these things is if you're using a lot of them, right, and you want to make sure you don't run out of indices. I didn't try that experiment yet, by the way. Maybe I should do that. But first, let me just show you. I'll run up to here. I wouldn't have printed it out yet, but we can see in the debug view, we can see this structure, and everything looks right, and everything's lined up correctly. This, as you know, the thread information blocks is at FS0, and this happens to be offset 18, so I call that P this. It's a, the address of this is that, so this is just a repeat of itself. You could click this forever, and it just occurs forever. Oops, I don't want. Here's the TLS slots, and it says I trace it out here at program start. that the index is 16, and I've put a value of, for the main thread, my initials 4 times over. Easy to recognize, and there it is. Everything else is exactly as you would expect, like before. Well, there's one thing that I was a bit surprised about, I should say. Okay, now this real process ID comes back with a number, that's good. But there's no real thread ID. I'm not sure what that means, and I'm not sure if this is correct. I don't know how to check it. Maybe another program prints it out. All this stuff appears to be empty. This is a great big buffer. It's all zero. Oh, no, it's not all zeros. There's something in there. Okay. There's a little, there's another bit there. And there, okay. So it's not completely empty. This is not, the format of this is not given. I'm sure it can be found out. And that's the GDI, I must have made up this name, TIB, thread environment block, something like that. I'm not sure about these spare bytes. This always seems to have something in it. Activation context. Looks like a pointer value. Probably is. Oh, sorry, activation context stack. Okay, some 132 line information. Well, it really needs starting at the top, shouldn't I? Now, the first thing is, as I said, the thing that we're going to look at in the next video. The structured exception handling frame, the first frame, or the 0th frame. It's actually the last. They go on in reverse order. It's like it is a stack. This, the top of stack, is the top of my program stack, my main the spread stack. So from 12. Now we can actually work it out precisely. We have the top and the bottom. In decimal, top of stack, 13, 1, 2, 3, 4, minus 1, 2, 8. Did I do that right? That does say bottom of stack. Yeah, no, these are almost the same number. Okay, that's a different stack then. Can't be 24. This looks like the top of the stack. And here, this could be right for the top of the stack. Now, this doesn't seem right at all. But it could be. It could be. That could be what's just been allocated, right? Then there's that page guard, and it'll grow when it hits a page guard. Probably is. Now, fiber is something like thread. I don't know much about it. Process ID, thread ID, these all agree with operating system. This here points to itself, which I presume means it's not used. There might be information in here. We knew the structure of this thing, environment block. So there's some kind of, it certainly looks like there's lots of data in here, but I don't know the format of it. The last error code, I would have printed that out in the printout. And I set the last 132 error to 8, and it's reflected there. And I believe that this is probably where it's stored in general. Like when you call get last error, I think anyway, this is always set back to 0, right? And the operating system does it on purpose. That's sort of what the intention is. But if you ever wanted to peek at the last error without changing it, you could use this method. You look it up in the thread environment block, in the thread information block. Again, Win32 information. That's not a pointer, or if it is, it's not valid. Doesn't look like. Thread information. FE. It's not that far away. I'm not sure, but it couldn't be that. I guess it's possible two things being wrong in the opposite direction could cancel themselves out. These blocks. I put in the right numbers. I double check. I've got it all written down on the side here. I double checked, that everything was right. I didn't print. I should print. I should take this and just print out offset for each thing, and then just one time through. If there's a difference, beep. Okay, and locale looks correct. Not sure if these things are correct. There's no way for me to check. So that's that, and that works. And as far as the for those other threads, the ones using the thread class, this is like before. This is one of those structures, which I've still got it here. That's the wrong address. It should be this address. The only way for me to get in here is to double click, so I have to stop the recorder. So that's giving everything's correct, and the thread ID is there, and the string, and everything's fine. So there's a wealth of information in this structure, and I think that probably I'll be making a lot of use of this struct in the future for various things. Now, so for the next one, I have something planned, and I just need to work out a few little details. Bit of a surprise, something that hopefully you'll find interesting or amusing, I don't know, one or the other. So hopefully that won't take too long. So be prepared for an upcoming little magic trick, let's say, the next one. Okay, see you then.